Okay, guys, this says an engineer is designing a roller coaster for younger children and had tried some functions to model the height of the roller coaster during the first 300 yards. She came up with the following function to describe what she believes make a fun start to the ride. So this is just the first 300, okay? 300 yards. Where h of x is the height of the roller coaster in yards. When the roller coaster is 100 x from the beginning of the ride. Answer the following questions to help determine at what distance from the beginning of the ride the coaster was. Okay, does it sound like a fun ride? Does this function describe a roller coaster? So if you plug in 100 for x, okay, no, that's not what we need to do. We just need to look and see, would this be a fun roller coaster? So, you know, whenever you think about a roller coaster at the beginning, it's going to look something, you know, where it's traveling up and then it starts to fall, right? So I guess it all depends if it's fun, if you like roller coasters. If not, then you're not going to like roller coasters, right? Okay, so can you see any obvious x values from the equation where the roller coaster is at height 0? So yeah, because if we plugged in 0 for each of those terms, we're going to end up getting 0. Okay? If we plug in 0 for x, it's going to be x plus, or 0 plus 0 minus 0 plus 0. So all that's going to equal 0 for that. Now it says using a graphing utility, graph the function h on the intervals 0 to 3. Why are we only doing 0 to 3? Because remember, 0, or not 0, but x is 100 x yards. So that would be up to 300 yards, like the question was asking for. So if we do that, you're going to end up actually getting something that looks like this. Okay. So if this is 3, this is 2, this is 1, this is 0, it's going to look something like this. Something like that if you were to actually graph that. So what does the x values you found in part C mean in terms of distance from the beginning of the ride? Well, we can see that at 0, at 200, and at 300 yards, 200 yards, 300 yards, it's going to equal 0. You're going to be at ground level. Now it says, why do roller coasters always start with the largest hill first? Well, they've got to be able to, you got to climb this hill so that they can use gravity to give it the up and downs for the rest of the ride, right? So it says, verify your answer. So this would be gravity flow, I guess. I don't know what you would call that, but verify your answer to part C by factoring the polynomial function of h. Okay, so it wants us to factor it. Let's factor this problem then. Let me scroll up here and see if I can't. Okay, let's do this. If we have negative 3x to the 4th plus 21x cubed minus 48x squared plus 36x. What? Okay, we factor out an x for sure. We can factor out a 3 for sure. So let's just go ahead and factor out a negative 3x. Leave this with x cubed plus, actually that's going to be a minus 7x squared plus 16x minus 12. Okay, so that's factored. Doesn't tell us these zeros or anything like that. But I can just about tell you, I'm going to erase my beautiful little drawing here. So if we know at 200 yards and at 300 yards and at 0 yards, it's going to be 0. That's our zeros. So I bet you there's some way for me to factor these out, this polynomial, where I get a 2 and a 3 as our 0. We've got our x to the 0 right here with our negative 3x. That's going to equal 0. Let's just see. Let's try and factor it and see what happens here. So the only thing so I'm going to have to basically do a little cheat here. Since I know 3 is going to be a 0, I'm going to say x minus 3 is a factor. Now, if I factor that out, what is that going to leave me? I'm just going to have to do it. Okay. So y'all know how to do this. We're going to simply divide x cubed minus 7x squared plus 16x minus 12 by x minus 3. So how do I get x cubed from x? I'm going to say x squared, x cubed minus 3x squared. Negate that, I get negative 4x squared plus 16x minus 4x. That's going to be negative 4x squared plus 12x. Negate those. That's a negative. That's going to be 4x. 4x minus 12. And that works out good because we want plus 4. That's 4x minus 12. And we negate that. Okay. So definitely a factor. Okay. And I bet we can factor this out to get our 2. So let me do that. Oh, sorry. Okay. So let's take this, and is this going to work? Yeah. I can say x minus 2 and x minus 2. So there's my 2, and there's my 3, and there's my 0. Cool. Okay. All right, this says to graph each of the polynomial functions for the function 0 counting multiplicities. What are the solutions of f of x when it's equal to 0? Well, that's just like setting it equal to 0, right? So let's see here. we're going to have 0, 1, and -1, right? So how would we graph that? Well, that's a beautiful straight line here. Okay, this is 0 in the middle. Let's call this 1. Let's call this -1. And so what's going to end up happening is something like this. Okay. And we know that because I told y'all the degree is going to be 3, right? If we were to do distributive property, that's to the third. So there's 3 solutions, and they're going to end up pointing in the opposite direction. Okay. So what are the X intercepts? Well, -1, 0, and 1. How does the degree of the polynomial function compare to the X intercepts? Well, they're the same amount. The degrees are going to be equal to the solutions there, or the X intercepts. Let's go again. Let's see here. All right. So you can look at this and say there's going to be, all right, there's going to be 4 zeros here, right? We're going to have we're going to have 4 zeros, and they're all going to be -3. So let's say -3 with a multiplicity of 3, right? Or, I'm sorry, with a multiplicity of 4. Right? The X intercept is only going to be at -3. The only solution is -3. Here we have the degree is 4. That's going to be greater than the X intercepts, right? There's only one X intercept. So what is that going to look like? Now let's draw this. I know this is not perfect, but if we go 1, 2, 3, -3 is right here. I know 2 things. Since my degree is to the 4th, I told you, even exponents, even powers, the end results are going in the same direction. So I know it's going to look something like this. Well, if that actually hit at the -3 X intercept, okay, this is going to look something like this. I cannot hit that X intercept. I can if I do it like this. There we go. They're going to both be going in the same direction because it is an even power. Okay. Let's see what else we got here. We have 1, 2, 3, 4, 5. That's going to be X to the 5th if we're to multiply all that out. So I'm going to have 5 solutions. I know that's going to be. Let's go from least to least to greatest. -4, -3, 2, 1, and I'm going to have -4 with a multiplicity of 2, right? It's going to happen twice. I'll just go ahead and list it twice here. Now, what are going to be my solutions? Well, my solutions are only going to be -4, -3, 2, and 1. And that's going to be the same as my X intercepts. That's going to be the exact same. But we have 5 degrees and only 4 X intercepts. Okay, so what is that going to look like? Well, I don't really know, but I can just kind of show you a little graph here that's going to make it try and make sense to you. This is going to be an odd power So I know that they're going to be going in opposite directions. So let's go with, let's call this -2, just so I'm gonna make it a little bit bigger so you can see. That would be right here would be -4, 0, and let's go with 1 and 2 would be here. So -3 would be right here, right? So I know I got to hit -3 and -4 and 2. So it's going to look something like this probably. Hit here. Let's try this again. Probably going to be something like this. I'm going to hit it here because it hits twice at -4, right? So that means it's going to come up here and then drop and hit there and up. Missed that right there. So here, up here, down through that, and then back up through there. Because it hits the -4 twice, I know it's probably just going to touch it and come back down. Okay. Let's see here. Hold on 1 second. Okay. So here we have, I can already tell that we're going to have 4 degrees, right? X squared times x is going to be x to the 4th. So that's going to be the number of degrees that I have, not necessarily the number of solutions or the number of X intercepts, right? So let's see, what is our solutions going to be? Well, I know that 2 and 3 is going to be 1, and well, x squared plus 1 is equal to 0. Well, x squared equal to -1. When is that ever going to be the case? It's not. Those are not going to be real solutions. So this is going to be my only 2 X intercepts or my only 2 solutions. But I have a degree of 4, which means the end result of my graph here are going to be going in the same direction. So if I said, let's see, this is 2, this is 3, and I plug in 0 for all this, that's going to give me my y-intercept, which would be 6, I guess. 1, 2, 3, 4, 5, 6. We haven't talked about this yet. But if I do that, I know that it's going to come down through here like this somewhat. And it's going to hit and then come back up, straight up through there. That's what it's going to look like. That would be your graph for this one. All right, let's keep going. 6, or page 6 at least. All right, this one is x cubed minus 13x squared minus or plus 44x minus 32. Okay. Let's look at this. Did I skip some? I'm gonna skip some. Let me look at this again. No? Okay. All right, let's go with, actually I do want to do one that I don't have on here. So I'll do it right here. One of them says alpha of x is equal to x squared plus 2 and all that is squared, okay? So if we sit here, we know that x squared squared is going to be the 4 degrees, right? This is not the problem above it. This is just one I'm making up. So we got 4 degrees here. Now, what's going to be the solution, okay? So we would have x to the 4 plus And we go blah, 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 blah. But we don't want to do that because we're trying to find the factors because that's what gives us our zeros. Okay. So how are we going to figure these out? Well, if I said x squared plus 2 equals 0, I'm going to have it 2 times. Well, what's x squared equals a negative 2? We can't do that. So there's no solution, which means there's no X intercepts. So what would that graph look like? Well, it's going to look something like this. It's just not, it's going to be a parabola, basically, but it's not going to touch the X intercept. Okay. So now let's do this one. It says use the fact that x minus 4 is a factor of F to factor this polynomial. All right, so that just means we have to factor out an x to the 4th. So if we did that, we have x minus 4 minus 4. And x cubed minus 13x squared plus 44x minus 32. Okay, let's scroll back up here. All right, well, we're going to have x squared because we got to get x cubed. That's going to get us negative 4x squared. Got to negate that, which leaves me with negative 9x squared plus 44x. I need 9x, negative 9x. I'm going to say negative 9 gives me negative 9x squared plus 36. Ooh. There you go. Yeah, that should be 9x. That'd be giving 9 squared. Okay, good. Now we're on the right track here. If I subtract that, that's going to be 44 minus 36. And that is 8x minus 32. And I need a positive 8. So that makes 8x. And that gives me a negative 32. Negate that. Okay. So x minus x. Ooh. X minus 4 times x squared minus 9x plus 8. Okay. Now then, that's the factors. That's 2 factors. Can we go ahead and factor x squared minus 9? I think we can. So let's do that. Do x minus, yeah, that'll be 1 and 8. 1 and 8. So it's going to be x minus 4, x minus 1, and x minus 8. Those are your factors. So that find x intercepts. Well, x intercepts are going to be, we'll order them from least to greatest. That's 1, 4, and 8. At which x values can the function change from being positive to negative or from negative being positive? Well, when do they do that? Your x values become negative or positive at the x intercepts, right? So that's when they're going below the, or below or above the x axis, and that's when they become negative and positive. So it says to sketch the graph of f, we need to consider whether the function is positive or negative on the 4 intervals. Okay, so the 4 intervals are when x is less than 4, between 1 and 4, between 4 and 8, and when x is greater than 8. So why is that? It can only change at the x intercepts, right? That's when it's going to be telling us if it's a positive or a negative function. So it's always going to be above or below the x-axis after those intervals or in those intervals. At 4, it's on the axis. At 1, it's on the axis. At 8, it's on the axis. So every other time, it's either going to be above the axis or below the axis. Okay. So E, how can we tell if the function is positive or negative on an interval between the X intercepts? So what we would do is we would pick a point, plug it in, and see if that answer is negative or not, or positive. Well, if it's negative, we know that it's going to be below the x-axis. Okay, so let's do that. It says for x is less than 1, is the graph above or below the axis? Well, if it's below 0, or if it's below 1, let's just use 0. Let's plug 0 in. Okay. If we plug in 0 into the original function, it's going to leave us with a negative 32, right? We plug 0 in for all those x's. That's going to give us a negative 2. So it's going to be negative. All right. If we plug in something between 4 and 8, uh-oh, did I miss one? Is there? Yeah, we should have done from between 1 of x and 4. I'm going to plug in a 2. Okay. If I plug in a 2 there, what's that going to be? Well, that's going to be, if we work that out, we said 2 cubed, not squared, minus 13 times 2 squared plus 44 times 2 minus 32. That's going to equal 12. So that's positive. So this interval is positive. This interval is negative. So what do you think it's going to be for between 4 and 8? Yeah, it's going to be negative again, right? Because it's going back and forth. And what do you think it's going to be for greater than 8? It's going to be positive. And you know that by looking at the graph. So let's graph this. And we have, let's go with 1, 2. I can't do that because I don't have enough room here. So let's go with 1, 1, 2, 3, 4, 5, 6, 7, 8. So let's just count these as 1. Okay. And if we do this, we say we're negative at below 1. Okay. And it's actually going to be way below that, actually. That's not even good because we said it was going to be equal to a negative 32. So it's going to look something way down there. We're going to come up, and then we're going to come back down at 4. 1, 2, 3, 4. And then we're going to come back up at 8. 5, 6, 7, 8. Okay. And they go in opposite directions because it is an odd power. All right. Let's see here. Now, this says, let's see if I can move this. Graph, move. It says graph it using a graphing utility 09 and compare your sketch with a graph generated by the graphing utility. And so what I'll do is I may graph that for you and show it to you during class. Let's just skip that and go on for now. Okay. All right, so we know these degrees of the polynomial. Well, this is going to be 2. How many intercepts? 2. Number of relative maximums and minimums. So we haven't talked about this. but maximum minimums are, I think maybe, let me see if I gave it to you on the lesson summary here. Yeah, okay. So relative maximum will be the function whose domain and ranges are subsets of real numbers. The function has a relative maximum at C if there exists an open interval of the domain that contains C such that, okay, if F has a relative maximum at C, then the value of C is called the relative maximum. So it's all about where can you have a point at, or a change, okay? So here, your relative maximum and minimums, you only have one, right? And it would be right here. Because we can't have a maximum or minimum on the other side. So here, we have a degree of 3. We have 3 X intercepts, and we have 2 relative maximums up here and a relative minimum down here. Okay, here we have 4 degrees. We have 1, 2, 3, 4 X intercepts, and we have 3 relative maximums and minimums. Okay, so we can always say, I think this probably is supposed to say, I can scroll down, not letting me. Okay, so the question below it says, consider what's going on here. So when we have the number of X intercepts, we can always subtract 1 from it, and that should give us the relative maximum and minimums. 2 minus 1, 3 minus 1, and 4 minus 1 are all going to give us our relative maximums and minimums. It's 1 less than the degree or the X intercept. Okay, let's look at it again. I think there's another 3 more of them. Okay, so here we have a degree of polynomials. Well, this one's going to be 2. How many X intercepts are they? None. And so this would be 1 relative minimum. So it's always going to have to look at our degrees and not our X intercepts. Here we have 3 as the degree. How many X intercepts do we have though? We only have 1 X intercept. Well, how many maximum and minimums are they? Well, there's 0 for this one. Right? I can't tell whether there's a maximum and a minimum at. All right, so let's keep going. Here we have a degree of 4. We have looks like just 1, 2 somewhere. So 2 X intercepts. And then we have how many maximums and minimums? Well, the only one I can tell would be this minimum down here, which is 1. So is it always going to be our 1 less than our degree? Can we say that? No, it does not hold. Okay, that's not true. So how can we determine how many maximum and minimums they are? We can't. Okay, there's no way of knowing for sure if there's a maximum, how many maximum and minimums there are. The best we can say would be if we take the degree of 2 and we subtract the 1, that's going to be 1. We can say at most there is 1. 3 minus 1, we would say 2 at most. Okay, but we cannot say for sure. Okay. So for the other, so we can go at that another way, right? If I said there's a maximum of 1, what would that mean if I said, okay, if there's a maximum of 1, all I could say is that there would be a possibility of having a degree of 2. right? It would have to be at least 2. But I couldn't give you any more information than that. I could just kind of give you an estimation. Okay, there is some terminology for y'all to learn or to know, but that is it for this video.